Hi everyone, welcome to the JVM Thing as part of Leeds Digital Festival. Thank you very much for joining us this Wednesday afternoon. It's been a long 15 months actually since we've hosted JVM Thing, so it's very good to welcome you all back. I hope everyone is keeping well. Just to give you a bit of context for anyone new to the group, so the JVM Thing has been running now for around 3 to 4 years. The JVM Thing is basically a tech networking group for the JVM language community to bring together software enthusiasts to share and show people and share knowledge around anything related to JVM ecosystem. We are on Twitter. We've been a little bit quiet over the past 15 months for obvious reasons, but there's our Twitter link there if you want to follow us on Twitter. Just to give a bit of context around Fruition IT, if you haven't heard of us before, we are a specialist IT digital tech recruitment business. We're based here in Leeds. If anyone has any or needs any support with recruitment in terms of needing to build out their team or replace members of their team, or if anyone is looking for support in terms of finding new job opportunities, then obviously feel free to reach out to us. Part of our service is running a career health check, which is completely free of charge, and it's a service that we provide to all of our candidates. We can offer advice around salary benchmarking, hot and in-demand skills, your experience, what you should be doing in terms of learning and development, trends in the market and CV building. So if you would like to take advantage of that free service, then do feel free to reach out to myself or Andy. The market right now is incredibly hot. I've never seen it so busy in 11 years in recruitment. So if you are thinking about what's next for your career, now is a fantastic time to start looking. And myself or Andy would be great, happy to support you with that if needed. Andy, I'll let you introduce Alexey, who's joining us today.
Thanks, Matt. So Alexey is a solutions architect at Depop.
Andy, you can't hear you.
Can you not hear me? Can you hear me?
I can hear you well.
Oh, you can hear me. I'm sure they can hear me. So Alexey is a solutions architect at Depop. He's driving the upskilling of the engineers to Kotlin, including some of the mobile devs, which is really interesting. On top, he's also an author of several books, which I'm sure he'll mention throughout the presentation. He's going to talk today about the bespoke Kotlins that they developed at Depop and some of the pitfalls to avoid. So I'll hand it over to Alexey now.
Great, and I'll just stop sharing my screen, Alexey, and obviously you can start to share yours.
Thank you very much for the introduction. I will now start sharing my screen. As Andrew already introduced me, you know who I am. My name is Alexey Soshin. I'm a solution architect at Depop. Have been with Depop for about a year. Prior to Depop, I was a principal engineer at Wix. And today we are going to talk about writing your own plugins, or in their previous name, features, for the Ktor framework in Kotlin. So I want to cover what plugins are, how they work, when you want to develop your own custom plugin, and walk you through how to develop one in a live demo. So let's get started. First, briefly about Depop, if you never heard about us. So we are a marketplace for fashion. We have about 25 million users globally, 30 million items listed, and more than 100,000 items added every day. In terms of engineering, we are about 150 engineers at the moment, and we have about 200 microservices, which are currently mostly written in Scala. For the past half year, we were evaluating adding Kotlin to our tech stack, and there are a number of reasons for that. First, Kotlin is easier to learn than Scala. It has less features. Scala is known to be a very feature-rich language, but it makes it hard to master. Kotlin is simpler. And it's especially easier for developers that aren't coming from a functional background, because Scala nowadays is very heavily functional based. Kotlin's syntax may be familiar for both Java developers and Android developers. It's pretty close to Java, and Android developers use it as their main language. Another reason we were looking to alternative solutions was that in Scala we use Play framework, and it isn't particularly the fastest framework on the market. It's quite slow. So it's not well suited for things like proxying API calls, for example. The reason we proxy a lot of API calls and need very high throughput is that at Depop we adopted backend for frontend architecture. For those that aren't familiar with backend for frontend pattern, or BFF in short, the idea is that each domain has a service that formats the responses in a way which works best for the mobile and web clients. We have around 40 microservices in the backend for frontend layer at the moment at Depop. Those services mostly proxy calls to other internal services, and they deal a lot with composing responses in the most suitable way. A Play framework that we use in Scala specifically struggles with such work. So theoretically, we could rewrite our BFF layer using some other Scala framework, but we decided to try Kotlin and Ktor instead. We wanted to adopt Kotlin because, as I mentioned earlier, it's closer to our mobile engineers, both Android and iOS, and we wanted them to own that piece of architecture by themselves and to be able to change it easily. And we chose Ktor framework for Kotlin because it's idiomatic, it's developed by JetBrains themselves, authors of Kotlin language. It's productive, and I hope I will be able to demonstrate that later on, and it's performant enough for us. One of our main requirements from those new Kotlin services was that they would report the same metrics as the Scala ones. At Depop, we have a lot of tooling built around our monitoring, like auto-generated Datadog dashboards. And ideally, we wanted to reuse all of that infrastructure in our Kotlin services as well. So we wanted to develop we wanted to make as few changes to our infrastructure as possible. So really, the problem that we were trying to solve is not so much about Kotlin versus Scala, then more about how are we going to integrate those Kotlin services with our Datadog infrastructure, same way we do that with Scala. So after introducing the problem, let's discuss about cross-cutting concerns in web development a bit. There are a lot of cross-cutting concerns that web frameworks need to solve nowadays. Monitoring is just one of them. There are things like logging. You want to log the same way across all your services. Templating, if you're outputting server-side HTML, headers, dealing with headers correctly, authentication, content negotiation, like parsing JSON and marshalling objects into JSONs, and so on. So there are a lot of those concerns that each framework tries to handle. Different frameworks have different approaches for handling those cross-cutting concerns. So Spring Boot, for example, which many of you probably familiar with, uses annotations a lot. Vertex is another framework in the JVM world that uses generic handlers, which acts as a chain of filters. And it's the same approach if we go to the JavaScript world, to frameworks like Express, for example, it will use the same filters approach. And Ktor calls handling the layer that handles those cross-cutting concerns plugins. So if you look at the Ktor documentation, it has solutions for almost any of the cross-cutting concerns that I already mentioned. There are plugins available and maintained by JetBrains for monitoring, for logging, for different templating engines. And there are plugins that set particular headers or handle headers in a particular manner. And there are plugins for authentication, plugins for marshalling and non-marshalling responses, and so on. The problem, though, is that since most of them are already provided and maintained by JetBrains, there isn't much documentation on how to develop your own custom plugins if you need to. If the default plugins suit your needs, that's great. But for other cases, it's a bit hard to figure out what you need to do to develop your own plugin. I mentioned that Ktor has a solution for cross-cutting concerns. So for plugins, there are two that are available. One is Micrometer and another is Drop Wizard. So those two are monitoring plugins, but they didn't suit our needs. As I previously said, we wanted to report the same metrics from Ktor service as our Scala service. And in Scala, we use common framework that reports those metrics in a particular way. So we decided to build our own plugin. Today, I'll take you through how to build your own monitoring plugin, hopefully in 20 minutes or less. I already prepared a project that starts a Ktor server and responds with some simple text. And also, it will fail randomly. So that's our Ktor service. As you can see, it's pretty easy to start it. That's all you need to do in order to start your service. And what this service will do is for any type of request, it will wait for 10 milliseconds. It will roll a random number. 10% of the time, it will throw an exception. And in all other cases, it will return us a valid response. I also created a mock metrics client that I will use. So here I initialize it. And if you ever worked with statsd, it's the same API, but instead of sending metrics, it will just print what happens with that request to the console. So it's the same API where you have report for success, way to report your success, way to report your failure with an exception, and fraud method to track how much time the request took. Okay, so let's start. Let's try to implement that plugin. So first thing we need to do is to install our plugin. And in something like Vertex, I would add another call to the call chain. Here, we say that we install a plugin, so it would be applied to our application. So I'll say install. And I'll give a name to that plugin. We don't have a class yet, so let's create it. And now our ID will suggest what we need to do next. So Kotlin and Ktor are pretty well integrated with the ID. So some of the hints the ID gives are very useful. So it tells us that we need to implement something called companion object. To those that are less familiar with Kotlin, companion objects are basically a static factory method that we need to implement. So it's a way to initialize our class without the need to call a constructor. So that's how we define companion object in Kotlin. And that companion object implements application feature, telling Ktor framework that this will be a plugin for our server. So let's look at the signature, at the types of application feature. Let's try to understand what's going on there, because there are 3 types and it's pretty complex. So first part is what part of Ktor application this plugin will operate on. So there is a server part, there are client parts, and so on. So this plugin will operate on application on the server. Second part is the class that will help us configure that plugin, and we'll implement it in a second. And the third part is the type of the plugin. So it's the same as our class name. Next, let's implement the configuration. So in the meantime, it will be just an empty class in Kotlin. And let's allow IntelliJ to generate the code for us. So IntelliJ generated us the code, and you can see that we have 2 methods to implement. Let's start with the one that is a bit easier. So the type of key that our plugin has is attribute key. And that's what helps this plugin to register inside the Ktor framework. So each plugin has a type, and we already defined that type using the generics here. So all we need is just to declare that object that will represent the type of our plugin. That way, Ktor framework will know whether that plugin was already registered, or we are trying to register a plugin that was applied once already. The string it gets is not significant. It's just for debugging purposes. So if you want to give here some kind of plugin description, it just goes in this string. But the actual way that the plugin will be recognized is by its type. So every plugin will have its own type, and that's how Ktor framework will recognize it. So it's a very smart way to have a type-safe registration. Instead of trying to align some identifiers like many other frameworks do, or just allowing you to register same plugin or same filter many times, Kotlin and Ktor take a different approach, which is much more type-safe. So we implemented the key. Now our plugin can be identified by Ktor. Let's move on and try to implement the install function. Install function is where all the interesting stuff, all the business logic of our plugin really happens. Before we can start implementing it though, let's go back to our code, to our server, and remember that we wanted to use that metrics client. So let's pass it. And we want our plugin to use that metrics client. So we will also pass it in the configuration block of that plugin. So this part tells that I want now to install that plugin, and this is the configuration for the plugin I'm going to install. So I will pass the metrics client, which is a mocked metrics client that I showed earlier, to that configuration block. Now, metrics client is an object, so I need to store it somewhere in the configuration. So let's go to our config. And now this metrics client will be stored in the configuration object. So if you remember the signature, the types that our client has, it has 3 types: what it operates on, how it's configured, and what it returns. So that's why we need to specify what type the configuration is. So it will be, so our IDE and also Kotlin compiler will be able to validate that and to autocomplete the properties of the configuration of the plugin. So this just stores the metrics client. Now to get it in our business logic, in the business logic of our plugin, we need to fetch it from the configure block. So what we do is that we unwrap the configuration and get it into the configuration variable. It's quite a common pattern where you supply a block, a lambda to your function, and then to unwrap that lambda to get the results, you use apply. It will also copy everything that was passed in the block. So the install function is thread safe, and it's very important, especially for things like servers that are very concurrent. We also know that, and we have a compilation error here that says that we promised to return an object of type server monitoring plugin. So let's do that now. So now our code compiles. If we try to run it again, and the plugin will be installed. It doesn't do anything useful, but what it does, it reads the metrics client we pass to it. It doesn't use it in any way, but it's able to read it, and it's able to return the plugin that is registered in the Ktor framework. Now we need to go back and discuss some more theory about how plugins work in Kotlin. So every request in Ktor has a lifecycle. And this lifecycle is represented by an object called pipeline. For a server request, we have setup phase where Ktor prepares the call. Then we have a hook for monitoring. Then we have the parsing of the request. And finally, we have the call phase, the invocation of our business logic. And actually, there are not one pipeline but two. So there is one pipeline for request and another pipeline for response, and they are identical. So we go through one of them when we receive a request. We usually transform bytes into some kind of object to be able to work with that in our business logic layer. And then our business logic returns us some object, and we need to transform it back to JSON or something else, and also set correct headers, monitor it, and so on. So that's why we have two pipelines, one for input and another for output. We will focus on the monitoring phase of the request pipeline in this example. So we will focus on that part. Let's go back to our code. And here you can see the pipeline that I mentioned earlier. To add a logic to a certain step of a pipeline, we use an intercept method. So here we added a lambda, some block of logic currently empty, to the monitoring phase of the request pipeline. If you don't want to do anything, you use proceed. So it's similar to in some other frameworks and languages, it's called next. It will just move to the next part of the pipeline, or if you have multiple plugins on the same stage, then it will just move to the next stage, like do nothing. And the nice way that Kotlin is structured is that it's not using callbacks, so there's no need to use something like then and things like that that you may be familiar with. Instead, if our proceed, if one of the next plugins or the business logic threw an exception, we just can catch it using a try catch. So let's wrap it in a try catch. If everything went well, we will invoke the success. And if we caught an exception, we want to report a failure. So now let's see how we implement those. We have our plugin. Now let's store it in a variable. Pass it the configuration. And now what we need to do to be able to report success or failure is to implement those methods. So we'll use a default implementation for that. And also for this one. Sorry. And let's also pass the configuration. So remember, we have that metrics that we started with. This is our mock metrics client. It's located in the configuration. So we get that client. And now if it's a failure, for example, then we want to say that we increment the failure. If we want to report the URL that failed, we would use the call, which is the current request, and we'll fetch the URI. And we also can propagate the exception. If it was a success, then we'll use increment success. And again, we will use the the URI. So that's it. Let's restart our server and see if everything compiles and works. And you can see that my plugin started to report the requests. If there would be, like, as I said, this our business logic fails every 10th request on average. So if I do a few more requests, you will see that it also reports the errors that it's got. So that's pretty cool. In 15 minutes, we managed to implement our own monitoring plugin. Let's try to stretch it a bit and also use the third function that reports time. Reporting time is a bit more tricky because when a request arrives in our pipeline, we need to remember somewhere when did it arrive. And after we processed the request, whether it was a success or failure, we need to fetch that timestamp from somewhere. And we need to calculate the difference between when the request was received and when it was successfully handled. So let's start with adding a before function. And we'll also have a after function. So one will be storing some timestamp when the request arrived, and another will be calculating the delta. So on the call, on the context of our request, there is an object called attributes, and it is used to store exactly data such as the timestamps for the requests and so on. So the way it works like a map. So it has a key and a value. And the interesting part is what type this key is. So if you followed me on how the plugin itself is registered, the attribute key is registered in a similar manner. So we have an attribute key, and the string doesn't really matter. It only matters what type of this key, what type this key is. So here we will declare a new class. Let's call it metrics. And we know we want to save for each request the timestamp. So we'll save that on the metrics. So what will happen now is that for each request, we will register a timestamp on the context of that request. So it's kind of thread context, but it works for coroutines, so it's much more concurrent. What we need now is to fetch that timestamp and to calculate the delta. So let's do that. This is called configuration. So since attributes is a map, we just can use the square brackets to fetch the value. And now we want on the configuration, we have the metrics client, and we want the time. We will report the request URI, similar to our other methods. And we will calculate the difference between the current time and the time that we saved. So this is long. This should be fine, I think. No. That's just my mistake while generating that. So I just made it a constructor instead of a variable. Okay, so let's look at that again. Before the call, we store the current time, and in the finally block, no matter if we got an exception or a successful result, we fetch the time we stored, and we calculate the delta between the two, reporting them. Well, let's see if that works. And you can see that it does report the difference as well. So we basically implemented, so in 25 minutes, we implemented a Ktor plugin that both reports success and failures, and also tracks the time of all our requests. And if we would have used the correct metrics client, we would be also able to report it the same way as we wanted it to. Okay, so that's it for the demo. Let's summarize now what we discussed today. We have created our own monitoring plugin that monitors Ktor services success rate, Ktor service success rates, and timings. To create a plugin, you first need to decide on which pipeline to operate. You need to decide whether it's a server client or a client plugin, if it's a server plugin or a client plugin or something else. Then you'll have to add a companion object with the key property to be able to register the plugins. Plugins in Ktor are type safe. And you will need to implement the install method that will wrap the correct pipeline at the correct stage. So basically it will intercept your request at the stage you wanted to intercept it, and then apply the logic. If you're interested in playing with the code, Here are the links for the fully implemented plugin, as well as the initial code that I started with. So if you want to make sure that you understand how it works, you can start with the initial one that is just a Ktor server without any plugins. And then you can try to implement that plugin and compare it to what I implemented. If you enjoyed the talk, let's stay in touch. I have a Medium account. I have Twitter that I try not to spam too much. I'm also author of a best-selling course on Udemy. So this course is about system design and architecture. As I mentioned at the start of the talk, I'm a solution architect. So I hope that you will enjoy that course as well. Last thing, this is my book. Please don't buy it. I wrote it 3 years ago. It's quite outdated. And nowadays I'm working on the second edition of that book. So if you will wait for November, when that book comes out, it will be much more relevant. And I hope that it will be very interesting to all the Kotlin developers. So yeah, that's it from me. Thank you very much. Thanks, Andrew and Matt, for inviting me.
You're welcome. Thank you, Alexey. Thank you for that absolutely fantastic talk. And it's well, you are very busy in your own personal time. Does anyone have any questions? I don't know if anyone has any questions that they want to ask Alexey before we wrap up. Can't see anything in the chat box, but I'll give everyone a minute to think about any questions.
If there are no questions, please feel free also to reach out to me on Twitter.
There's a question here actually, but if you can see it, Alexey, but question is going back to Depop. How are the mobile developers finding Kotlin for server-side development?
So I had those discussions. That's an excellent question. Thank you. So I had that discussion with both the iOS and Android engineers. And they find the language itself quite friendly, even for iOS engineers that aren't familiar with particularly Kotlin. It's pretty similar to Swift. There are certain challenges. Like it's not only about the language, it's also about knowing how to write server code and dealing with the infrastructure. And it's something that we are actively onboarding our mobile engineers on at the moment. Any more questions?
Brilliant, thank you for that. I think that's it for questions. Well, thank you very much, Alexey. Thank you for giving us that presentation. Really appreciate it. We hope to see you again. We're
Absolutely.
hoping to thing now. So hopefully we'll see you in 3 months, where we'll be planning our next session, hopefully in person. Fingers crossed. So thank you very much, Alexey, and thank you all for joining us. Have a good week.
Thank you all. Have a nice week.
Cheers, Alexey.